afternoon everyone. So welcome to the lecture number 4 of chapter number 7. In the lecture number 3 we have discussed about the congruency of triangle through SAS congruency. It means in between two triangles, if any two sides as well as the included angle, for example this side and this is the included angle, is equal to another two sides and the included angle of another triangle. If ABC and DEF are two triangles such that this side is equal to this side is equal to this side, and this angle is equal to this angle, then we can say that these two triangles are congruent through SAS criterion. This is the first condition of congruency. Now in this lecture we will discuss about the second condition of congruency, that is known as ASA congruency. What does mean by ASA congruency? Let's see. Suppose there are two triangles like ABC and DEF, and if in between these two triangles any two angles, suppose this angle and this angle, and the included side means the side which lies in between the two triangles is known as included side. Okay, so you cannot take this side. No, if you take this side, then one of its vertex is related to this angle, but another vertex is not related to this angle. You cannot take this side as included side because only this angle is related to it. So you have to choose that side which is the included side between the two angles. Since we have chosen this angle and this angle, then this is the included side. Understood? Now according to this congruency or this criteria, if any two angles and the included side of one triangle ABC are equal to another two angles and the included side of another triangle DEF, then we can say that these two triangles will be congruent. Understood? So you need to prove that if this side angle A is equal to angle D, angle B is equal to angle E, angle A is equal to angle D, angle B is equal to angle E, and this included side AB is equal to this included side DE, right? This is angle, this is side, and this is angle. Then according to the ASA congruency, these two triangles will be congruent. Okay, so this is our matter of discussion today. So we will now discuss how through ASA congruency these two triangles will be congruent. Since it is an axiom, so we do not need to prove it. No, we don't need to prove it. It is an axiom, it is a postulate, it is an assumption. Okay, we have discussed that an axiom is a self-proven statement. We don't need to prove it. But ASA congruency is a theorem, right? It is a theorem. Since it is a theorem, so we have to prove it by the help of axiom 7.1. This is the theorem number 7.1. Okay, so let us start with the theorem 7.1. Right. So let us first understand the statement of that theorem. So according to the theorem 7.1 or ASA congruency, this statement tells you that if two angles and included side, suppose there are two triangles, triangle ABC and triangle DEF. So according to the statement, if two angles, suppose this angle and this angle, or you can say this angle and this angle, and included side means we have chosen this side BC, right, of one triangle, which triangle of triangle ABC are equal to two angles, this angle and this angle, and included side, this is the included side of another triangle, then two triangles are congruent. Through which congruency? Through ASA congruency. Okay, so we have to prove that this triangle and this triangle are congruent. We have to prove this. It is not given. No, we have to prove it. Okay, so we have to prove with the following procedure. First, what we will write? First, we will write what is given in the question. Understood? So it is given that in triangle ABC and triangle DEF, this angle is equal to this angle, angle B, or you can say angle ABC, whatever you can write. Angle B is equal to angle E. It is given. Second point, this angle is equal to this angle, angle C is equal to angle F, or you can write ACB, no problem. Okay. And the third condition is that, or third given point is that this included side BC is equal to EF. Okay, so these three conditions are given from this statement. Okay, now to prove, what we need to prove? We have to prove that this triangle is congruent to this triangle. Triangle ABC is congruent to the triangle DEF. Okay, so our target is to prove that this triangle is congruent to this triangle by using the axiom number 7.1. That means by using SAS criterion, we need to prove that this triangle is congruent to this triangle. Okay, so proof. So here three conditions arise. Here we have three conditions arise. What are the three conditions? Let us know. It is not given that this triangle is congruent to this triangle. We need to prove it. First of all, you have to keep in mind this thing. Now three conditions arise. What are the three conditions? The first condition is that since this angle is equal to this angle is equal to this angle, this side is equal to this side, but there are no conditions about whether this side is equal to this side, or this side is less than this side, or this side is greater than this side. This condition is not given. So there are three conditions that arise. The first condition is that maybe this side is equal to this side, maybe, we don't know, or this side is greater than this side, or this side is smaller than this side, D. So these three conditions may arise. Okay, so we have to prove that this triangle is congruent to this triangle under such conditions. We have to prove this triangle is congruent to this triangle under this condition, under this condition, and under this condition individually. So let us start with proving under the condition AB is equal to D. It means when this side is equal to this side, then we have to prove that this triangle is congruent to this triangle. Okay, so let us prove. So let us prove the first conditions. The first condition is that we have to take that AB, this distance, is equal to D, that means this distance. We have to assume it, right? This is our assumptions. This distance is equal to this distance, or this side is equal to this side. Okay, so let's prove. Between triangle ABC and triangle DEF, we will compare these two triangles, whether they are congruent or not, if this condition is given, that this side is equal to this side. Okay, so first, see, we have assumed that this side is equal to this side. So write AB is equal to DE. Why? Because assumptions, we assumed it. Second condition. It is given that this angle is equal to this angle. It is given already. See, this angle is equal to this angle. It is given. Okay? So we can write angle B is equal to angle B. Why? Because it is given. Third condition. This side BC is equal to this side, isn't it? Yes, this side is equal to this side because it is given. BC is equal to EF. So we can write BC is equal to EF. Why? Because it is given. So this stands for side, this stands for angle, this stands for side. So in between these two triangles, these two sides are equal to these two sides. See, AB and D, AB and D, and BC and EF. So these two sides are equal to these two sides, and this angle is equal to this angle. Hence, we can write through SAS criteria, this two triangle will be congruent. Hence, triangle ABC is congruent to the triangle DEF by SAS criteria. Now it is proved. What we need to prove? We need to prove that this triangle is congruent to this triangle, and we have proved it for the condition that this side is equal to this side. Okay? So it is proved. So we can say yes, if in two triangles, any two angles like this angle, this angle, this angle, this angle, and included side means this side and this side are equal, then these two triangles are congruent. Okay, this is our conditions 1 or case 1. Now we'll move towards the case number 2, where this side AB will be greater than DE. Okay, so let's move to the condition number 2. So in the exam number 2, it is assumed that this side AB is greater than this side DE. For example, if it will be 6 cm, then you have to choose such distance in which this side is greater than this side. That means you can take it as 5 or 4 or 3 or 2 or 1, but not more than 6. We have assumed that this side is greater than this side. Okay. So by this assumptions, we have to prove that this triangle and this triangles are congruent through using SAS criteria. Okay, or axiom number 7.1. So let us prove. Since it is given that this side is greater than this side. Okay, so here we need to construct something. What is the construction? Why we need to construct? See, we have to take a point P on the line or on the side AB so that this distance is equal to this distance. Again I am saying you, suppose this total distance is 6 cm. This total distance is 5 cm. Right? Then we have to choose a point P on AB so that this distance PB is equal to this distance. It means what? It means the distance from P to B must be 5 cm. Because we have chosen P at the point so that this is equal to this. If it is 5, then it will be 5. Understood? Now, so we have taken P as a point on AB. So write it. Take P as a point on AB such that this distance PB is equal to DE. Okay, we construct it. Now let us join this two vertex P and C and join P and C. Right? Next thing. Now we will compare this triangle with the triangle DEF. Okay, So now we will compare the triangle PBC with the triangle DEF. Okay, keep in mind one thing, you have to compare this small triangle, not the total triangle. We have to compare this small triangle with the triangle DEF. Clear? And to prove whether they are congruent or they are not congruent. Understood? See, from the construction we know that P is such a point such that this distance is equal to this distance. We have constructed it. So this distance PB is equal to this distance. Okay. So in the first case, among this triangle and this triangle, we can write that this distance PB is equal to the distance DE. Why? Because we have constructed it by construction. Understood? Second thing, in this small triangle, this angle is also equal to this angle because it is given. Yes or no? See, angle B is equal to angle E. So we can write that angle B is equal to angle E. Why? Because it is given. Third condition is that in this small triangle, this side BC is equal to this side EF because it is given. So we can write BC is equal to EF. Why? Because it is also given. Now you can see among these two triangles, this side is equal to this side is equal to this side, this angle is equal to this angle. It means by side angle side, the two triangle will be congruent. So we can write that the triangle PBC is congruent to the triangle DEF by SAS. See, this is side, this stands for angle, this stands for again side, by SAS congruency. Okay, so up to this it is clear. So here we have proved what? We have proved that this triangle is congruent to this triangle. But our target is not to prove that this small triangle is congruent to this triangle. No, we have to prove that this larger triangle is congruent to this triangle. How? See, the next thing we have to prove that, see, it is already proved that this small triangle is congruent to this small triangle. Okay, look at it carefully. It's a very important question. So triangle PBC is congruent to the triangle DEF. It is proved. Now, we know if two triangles are congruent, then their corresponding angles and the corresponding sides must be equal by axiom 7.2. Since, forget about this line, forget about this. Okay, only consider this small triangle with this triangle, right? We know if the two triangles are congruent, then their corresponding angles must be equal. So we can write that this angle, which angle? This angle PCB is equal to this angle DFE. Why? By axiom 7.2. Understood? Now draw the first diagram. It is clear now? So suppose it is equation number 1. But it is given that in this triangle and in this triangle, this angle, total angle is equal to this total angle. See? C means this total angle is equal to F means this total angle. It is given already. Okay? So you can write, but this total angle means ACB is equal to this total angle DFE. Why? Because it is given. Okay? So it is equation number 2. Now see, this is equation 1 and this is equation 2. Now you can see in equation 1 in the right hand side we have DFE angle, and also in equation 2 in the right hand side we have DFE angle. And we know if in any two equations, if their right hand sides are equal, then we can write that their left hand side must be equal. Okay? Since the right hand side are equal, so we can write that this side is equal to this side. Okay. So from equation 1 and 2, what we get? We get this angle is equal to this angle, or this side is equal to this side. ACB is equal to PCB. This is the final result that we get from the equation number 1 and equation number 2. What it represent? It represent that ACB means which angle? ACB means this total angle is equal to PCB, this small angle. The larger angle is equal to the small angle. Is it possible? How? It seems to be the large angle. Suppose it is 60 degree, then this will be the 50 degree. Na? How 60 and 50 will be equal? But we have proved that they are equal, but actually they are not equal. Understood? By theorem, by exam 7.2, we have proved that both angles are equal. Then what will be the condition? Should be satisfied so that these two angles must be equal. Again, I am saying that this angle, total angle, is equal to this small angle, but actually it is impossible. But we have proved it, right? So there must be a condition, should be satisfied, so that these two angles will be equal. How? It is very simple. Suppose I will tell you. Wait for a second. See. Suppose this is the one side, this is another side, right? We have proved that this total angle is equal to the small angle. Then when they will be equal? If we shift this side PC to the side AC, if we shift PC to a side AC, then what will happen? Then this two angle will be equal. Again, look at it. If I shift PC like this to AC, then what we get? We get this two angle will be equal. Okay? It means we have to shift this point P to a point A, so that these two angles will be equal. Okay? So when it is possible? It is possible if we shift P to a point A, so that PC side is nothing but AC. PC and AC sides are equal. How? Like this. This is AC, this is PC, but we need to shift this PC to this point, to this side, so that they will be. So this is possible if P is shifted to A. P is shifted to A. It means what? Now the point P is not here. No. Now the point P will be here. And now this side is not here. Now this side will be here. Understood? It is clear now? Hence, P point is nothing but A. Now, P is nothing but A. The point P also lies on A. So, P and A are not equal, not different. They are equal. Understood? So, but we have proved what? We have proved that PB from the construction. We taken that PB is equal to DE. Remind this. I have erased it. Here it is written that such that PB is equal to D. It is written already. I have erased it. Okay. Now, but we know PB is equal to DE. We know it. But what we get it? We get whenever the point P is shifted to point A, then this distance PB is also equal to AB, because P is nothing but A. So PB is equal to AB. So PB is equal to AB. It is very important point. It is very important point. We have constructed that PB is equal to DE, right? But after this proof, we have to do what? We have to shift point P to A. But now that A is nothing but P, A and P are equal. So this distance PB is also the distance for A and B. So PB is equal to AB and which is equal to D. It is proved now. Okay. Now it is clear. Now we have to compare this triangle with this triangle. Our final conclusion is that we have to compare this triangle with this triangle. So P, now not P, you can take ABC triangle and triangle DEF, AB is equal to DE. Why? Because see, AB is equal to DE. We have proved AB is equal to DE. Why? Because whenever the point P shifts to a point A, then A and P is nothing but they are the same point. So this distance is common to AB is common to PB. But we know PB is equal to DE. So AB is equal to DE. Why? Because by proved. Second thing, this angle is equal to this angle. Already given that B is equal to E. Third point, this BC is equal to EF because it is given. F. Okay. Now you can see in the triangle ABC and on the triangle DEF, you can see AB is equal to DE. That means this side is equal to this side. Okay. B is equal to E. This angle is equal to this angle, and BC is equal to EF. Okay. So this is side, this is angle, included angle. So by SAS congruency, you can write that this triangle is congruent to this triangle. Hence, you can write that triangle ABC is congruent to the triangle DEF. Now, this is the final result that we need to prove that this triangle is congruent to this triangle. Okay, it is proved now. So let me tell you in details, in brief. First, what we will do? First, for the condition number 2, that AB is greater than D, we will do what? We will take a point P on AB so that this distance DE is equal to PB. Then join PC. Next, we will compare or we will make congruent this triangle PBC with the triangle DEF. These two triangles are congruent. Now, if these two triangles are congruent, then their corresponding angles must be equal. So we can write this small angle is equal to this angle. This is equation number 1. But we know that the total angle is equal to this angle because it is given here C is equal to F. This is equation number 2. Now from equation 2, after solving, we get that this small angle is equal to the large angle. But actually it seems to be impossible. How it is possible? It is possible if we shift this point P to a point A, or if we shift this side PC to a point A, so that the point P coincided with the point A. Hence P and A are not the different vertex, they are the same vertex. If P is substitute or shifted to a point A, then this distance PB is also equal for AB because this is a side for PB, it is also a side for AB. And we know this distance PB is equal to D, PB is equal to D from the construction, and we proved that this PB is equal to DE is equal to AB. Now we find that this side, the total side is equal to this side, and then compare these two triangles. In this two triangle, this side is equal to this side is equal to this side, this angle is equal to this angle. So SA or SAS congruency through A. So we can prove that this triangle is congruent to this, and it is proved. Understood?